Our example states, a 0.15 molar solution of chloroacetic acid has a pH of 1.86. What is the value of Ka for this acid? Since we're looking for the value of Ka, the overall goal is to find all concentrations at equilibrium, then plug those into the Ka expression. Let's take this step by step and start with identifying the given and what we're finding. We're given the molarity of our acid and the pH. We're finding Ka. Step 2 is to find the hydronium ion's concentration using the given pH and this formula. We'll plug in our pH into our formula to get this decimal. Don't forget about the sig fig rule for pH. The amount of decimal places the pH has equals the number of sig figs the concentration will have. Our pH has 2 decimal places, so our concentration will have 2 sig figs. Step 3 is to write the dissociation equation. We were given the chemical formula of our acid, and we'll add this to water. We now have our acid and our base. Recall an acid donates an H+ to the base. The base accepts the H+ to form the conjugate acid. Since the acid donated an H+, it lost an H+, so the conjugate base looks like this. Step 4 is to build an ice table. This was what we were previously given and the concentration we found in step 2. The initial concentration of our acid was given, so we'll place that here. We don't include water in our ice table because we don't include liquids in our Ka expression. Looking at the products, we are not given the initial concentration of hydronium. So be careful here. This is the concentration at equilibrium, not the initial concentration. Since we were not given the concentrations of our products, we will label this as 0 for both. And this value will go in row E for equilibrium. Our change is minus X for the reactant and plus X for our products. Adding rows I and C, we get row E. Notice we already have the value of X. X is equal to 0.014. We can now plug in this value for each X. Step 5 is to find all concentrations at equilibrium. Subtracting these values gives us this, and we'll round to 2 sig figs. This is the concentration at equilibrium for our acid. For our products, the concentrations would be the same value of 0.014. Step 6 is to write the Ka expression. Remember, we don't include liquids or solids in our equilibrium expression. Our products go on top, and our reactant goes on the bottom. Step 7 is to plug in the concentrations at equilibrium into our Ka expression. Multiply the top values and divide. We can write Ka like this or in scientific notation. Either answer is correct. For more help with acid-base equilibria, check out these resources.